Hey everyone, welcome to another CUBE webinar. This week we're talking about data app monetization and how you can do that successfully. We have Brian Bickle, our VP of Strategy and Alliances at CUBE, and with fellow speakers Ryan Boyd, the co-founder of MotherDuck, and Spencer Taylor and David Stoker from Astrodata, who are both co-founders there. But if you are new to our webinar program, I just want to go over a few housekeeping items. You can ask us your questions at any time during the webinar. Simply enter them in the question box, click submit, and we'll get to them during the Q&A portion at the end of the webinar. The recording of this webinar will be available on demand right after the live show. So if you want to review it, check it out on our events page, and we'll have it there waiting for you. And if you have any feedback, we would love to hear that. Just tell us how we did right after the webinar is done. And what we're going to cover today. So we're going to do a quick overview of CUBE and MotherDuck, introduce you to Astrodata and data monetization, and then share with you the MD Cure stack and provide a demo. If you have any questions on that acronym, be sure to ask those in the live Q&A portion of the webinar. So without further ado, I'm going to pass it off to Brian to get us started. Welcome, Brian.
Hey, thanks, Nathan. Yeah, everybody, happy to be here today. As Nathan said earlier, my name is Brian Bickle. I'm the VP of Strategy and Alliances here at CUBE. First, I'd like to thank partners with Astrodata for being here, and Ryan with MotherDuck for coming by. Both great partners of CUBE, and as an Alliances guy, it always makes me happy to get partners on webinars. So I'm going to go ahead and start off by telling us all a little bit about CUBE and maybe explaining CUBE if you aren't familiar with it or if this is your first webinar joining with us. CUBE is a universal semantic layer product. And if you aren't familiar with the idea of a semantic layer or like the key problem that we're solving in the market or that we're working on here at CUBE, the big idea is this model sprawl that we see in the modern data stack. And what we mean by that is the modern data stack is really broken down into a lot of different technologies that all have metadata in various places and all have a lot of information about data modeling all over the place. That could be data models that are defined within a data warehouse. That could be data models that are defined or implied within your transformations, whether that is an ETL tool or something else that's doing that. And then where it really gets out of control is when you start to look at all of the different business intelligence tools, embedded analytics or customer-facing analytics technologies, now things like notebooks or things like AI agents. They all have their own lightweight semantic models within them, and they all imply things like calculated fields or like just-in-time sort of like dimension mappings and lots of other things like that that imply the data structure. And what this causes is it causes a lot of challenges in keeping data consistent within the enterprise, and it causes a lot of what we think of as chaos in trying to ensure that these data models are all aligned and that users understand where data is coming from and how to use it correctly. So with CUBE in a customer's or user's environment, this is the way that prior slide changes. Universal semantic layers as a category typically fit between data warehouses. In today's demo and the stack that we're going to talk about today, as Nathan mentioned, we're gonna talk about this in conjunction with MotherDuck as a warehouse. And then the data modeling aspects are all centralized within the semantic layer, and different BI tools, customer-facing or embedded use cases like things like React in the prior stack we were talking about. Those would all just connect directly through a semantic layer, and we're going to go ahead and get into a little bit more detail about what's in the box with CUBE and maybe explain some of those functionalities. As a semantic layer, data modeling is kind of like the big idea or the thing that we all do, but there are some additional benefits that are maybe a little bit unexpected that a product like CUBE provides as a complete semantic layer. And that's not just data modeling, which is a code-first experience in CUBE. That can be taken advantage of with JavaScript, with YAML, with Python as the language. All of that is, by virtue of being code-based, it's something that can be versioned in Git. You can run software development lifecycle best practices on it. You can do things like, have multiple contributors interacting on the same data model, which is really nice. But after data modeling inside Cube, we have our next sort of pillar, which is our access control, which in the situation with a embedded analytic application, typically, if you're putting those in front of customers, you're in a multi-tenant environment. So access control, whether that's column level masking or column filtering, or whether that's row level security, becomes really important. You don't want to ever show customer A, customer B's data, especially in a monetization situation like we're talking about. So really strong implications or really strong guarantees about security are very important. And Cube makes that pretty easy with our security context model. Next, we have caching, which is provided by our technology called Cube Store. That is an aggregate-aware pre-aggregation scheme, meaning that if you define an aggregate on a dimension or on a time range or something like that, Cube will automatically maintain those aggregates for you, and we will rewrite queries to take advantage of the most performant aggregate that we have and to keep them up to date. So it's quite simple to manage. If you've ever done something like materializing a table in the past and then had to change your BI connector to use the materialized version versus the normal table, you don't have to do any of that with Cube. We handle all that for you. And then finally, everything leaves Cube via our APIs, which are REST, GraphQL, and our SQL API, which is Postgres compliant. So that's how we get connectivity to any kind of tool that you can imagine. And as far as maybe some of the benefits, if you're still not sold on why you want to bring a semantic layer into your stack, the big things that we're selling are trust and consistency, and making sure that all of the data models are consistent, and that if a user interacts with a dashboard in, let's just say, a business intelligence tool or a embedded analytics situation, maybe it's an app that's embedded in your own product, we want those numbers to be consistent. We want to make sure that we're accessing the same data, that we're getting the same values everywhere. Data security is provided, again, through our security and our role-based access control schemes. Performance is a side benefit a lot of people get through utilizing Cube Store. That can make something like a relational database or a cloud data warehouse experience quite a bit less load due to caching and due to pre-aggregation. So performance is generally a benefit as well. And then these last sort of three are stack flexibility, time to value, and future proofing are all really what I would bundle up again in developer experience, and just enabling developers to sort of abstract a lot of the ugly middle tier of data access layers and go faster because of that. And with that, I'm going to get out of the way and make room for our partners, and I'm going to pass it over to Ryan.
Hey, thanks so much, Brian. So, Brian talked about MotherDuck, which for a data team use case is very much a data warehouse. We have data teams using us to keep track of all the central data in their organizations and do analytics, BI, the semantic layers and all on top of MotherDuck. For the data app use case, which we're talking about today, the way I describe it is a serverless DuckDB platform for low-cost, low-latency analytics that combines the power of your laptop and the modern cloud. And I really want to talk about that last piece, because that last piece about combining the power of your laptop and the modern cloud is a key differentiator of MotherDuck. I like to say you can quack local and fly global. DuckDB has become super, super popular in people using DuckDB on their local laptops to run analytics, do exploratory searching of their data. And we think you should take advantage of the power of your laptop in addition to taking advantage of the power of the cloud. So, if you open up the DuckDB CLI on your computer and connect to MotherDuck, we actually decide which parts of the query should execute locally, which parts of the query should execute in the cloud. And we have a great query planner that's constantly improving around that, with some of the world's leading database researchers helping us on that. But if we talk about for data apps, the way a traditional data app is designed is really the three-tier architecture, where you have a client, oftentimes a web browser accessing a server, and that server then turns around and accesses the database to get the relevant data. And this works well for most of the applications we interact with on a daily basis. But it does, have multiple steps between the client and getting to the database. So, various folks have built platforms where you can access the database directly from the client, so web browser or a desktop client. And this is, what's called a two-tier architecture. And what I'd like to talk about here today, though, is a little bit different version of this, which we're calling the 1.5 tier architecture. And in the 1.5 tier architecture, you have your client, in this case, a web browser, your data app, and the database actually does get to run in the client itself. And that's how we actually do all of our work with DuckDB. On one side of the pipe is DuckDB running in your code. On the other side of the pipe is DuckDB running on our cloud servers. But in the case of a web application, what does that mean? Well, we use WebAssembly to run DuckDB in the client. And that means that a lot of your data can be materialized locally, filtered locally, and you can create these really fast video game-like experiences with your data, which you just couldn't do before when you had, inherent latency between your client and the server and the database. And, so this really has changed the way that we can do things. And a lot of the BI tools take advantage of this, but we're starting to see a lot of data apps being built to take advantage of this as well. The other differentiator that we have with MotherDuck is basically the way that we do our tenancy architecture. So in a typical data warehousing environment, you have this shared database, and all your users are kind of battling over that shared database. And in some organizations, they'll create a separate database for the higher profile users or the more important folks. But you still basically are having like this shared resource that all the users are accessing. And for a multi-tenant data app, again, you have that shared usage. With MotherDuck, every user gets their own compute. So we have ducklings, as we call them, which we spin up and are used to execute the queries from an individual user or customer in the case of a data app. And this allows them to basically be happy and be in control of their own destiny. And a lot of folks really appreciate that because, they've dealt with the pain of the other model. And so the tenancy and the idea of local and cloud execution are some of the big differentiators. And from the MotherDuck standpoint, this allows you to deliver this ultra fast in-product analytics built on a true analytics database. We find a lot of people start their analytics for their data apps on Postgres or another database that just really isn't designed for analytics. And then they migrate to one of the popular data warehouses, which is where the next advantage comes in. We say won't break the bank. We've started publishing some of our preliminary pricing. Today it is free. Get started for free. It definitely won't break the bank. But we plan on being super competitive for these types of use cases. And we can be because of the economics that we get with that architecture. So every user can kind of spin down to zero really easily. And then, of course, everyone loves DuckDB. You've seen the Twitterverse commentary on that. So those are some of the top reasons we think MotherDuck is unique, especially for data apps. and give us a try. Like I said, it's free for now. And I'm going to turn it over to Spencer, who's going to talk about Astrodata.
Thanks, Ryan. And hi, everyone. Thanks all for joining. I'm Spencer Taylor, joined by my co-founder, David Stocker, and we are Astrodata. We build data products that help our clients monetize their data. David and I have been working together for over 5 years now, building data products for companies of various size and industry. I will give just a quick background on myself and hand it over to David for an intro as well. I have a background in data. For the past 6 years or so, I've led data teams that build back-end data infrastructure that power data applications that David's team ultimately ends up building on the front end. David, do you want to give a quick intro yourself?
Yeah, hi, my name's David Stocker, and I come at this from a software product development standpoint, and I'm particularly interested in building experiences that meet the needs of a specific data user where they're at, allowing them to ask questions, gain answers, and take actions all within a cohesive workflow.
Thanks, David. Okay, so I want to talk a little bit about data monetization. It's a phrase that you've probably heard in common discourse. It's all over social media, LinkedIn. And I want to talk specifically about some common themes or characteristics that we see in data monetization strategies. First, analytics. Data products engage different user communities that may not well be served by out-of-the-box BI solutions or workflows. So we see a lot of kind of more complex or bespoke analytical patterns, such as benchmarking and cohort analysis, particularly benchmarking in the modern data monetization world, where companies have a big repository of data that could be valuable for an individual customer to take advantage of to see how they stack up against the broader population. Next is monetary value. Users need to feel, or customers need to feel like they are getting real economic benefit from the data that they're accessing via your data monetization play. You should ask yourself the question, can you deliver data insights that improve operational efficiency, top-line growth, or innovation? Next is omnichannel. A major goal in data monetization strategies is to meet users where they're most comfortable. You want to make users feel like they're in a cohesive experience, just like you would in a normal SaaS product. So whether that's web, mobile, desktop, push notifications, we see data monetization strategies span multiple different channels. Interactive. We see the need for data platforms to support data exploration and allow users to build custom calculations, drill paths, workflows that integrate data into other platforms. And so a lot of times we end up building self-service or data exploration features within a data monetization product. Data is also only valuable if it's actionable. So when we build data monetization products, we like to be able to build workflows directly into the application that let users take action on the insight that they've gained. And finally, real time. This isn't always present in every data monetization play, but it can be an extremely valuable way to monetize your data. You can think of use cases such as anomaly detection, where a customer may need to understand that there's a spike in web activity. Rather than just understanding that there is a spike, they also need to jump in and see if they can troubleshoot and take some action on that spike, whether that's blocking an IP address, or some other action. Okay, let's talk a little bit about the MD tier stack as we've coined it. That's MotherDuck, Cube, and React. We've already heard from the MotherDuck and Cube teams, so I'm not going to go into too much detail at a high level about MotherDuck and Cube. MotherDuck, hybrid DuckDB execution between laptop and cloud. Cube is an API-driven semantic layer modeled in JavaScript, YAML, or Python. And for the front end, we really like to use React, which allows us to build fully custom UIs and integrates with a variety of visualization libraries. There are three main advantages that we found with this stack. The first is profit, driven by a reduced unit cost and the ability to increase your customer acquisition. Value to customers, which is driven by low query latency and increased data reliability. And finally, this stack is familiar to developers and is easy to use. Developers are able to adapt and iterate quite frequently. Let's break down the profit category. When you're building data monetization products, you want to choose technologies that result in an advantageous unit cost as you scale up your customer base. The reason that we like MotherDuck and Cube so much for this category is they're both usage-based. They don't require additional license fees per user, which allows you to take advantage of economies of scale and create a highly leveraged pricing model. If you think about the converse, where a certain platform or tool may have an additional license fee per user, your pricing scales linearly as you add on new users, which doesn't take advantage of economies of scale. And a nice advantage that using a semantic layer provides is the ability to increase your customer acquisition by building a tiered pricing system. So as Brian laid out, one of the advantages of using Cube is that you get not just the data modeling aspect, but the authentication and data governance side. So as your customers are interacting with your application, they can be incentivized to upgrade to a premium tier, and via the React front end and the Cube API, their user profile can be updated instantly, and they can get access to new analytical patterns and workflows. Here's a quick pricing table that kind of outlines what a tiered pricing system might look like. You can see as you move up in pricing tiers, you gain more access to historical data, more granular data, you get more interactivity with self-serve exploration, scheduling, custom integrations, and you kind of move up that analytical pathway from descriptive to predictive to prescriptive analytics. Talking a little bit more about the value that these technologies allow you to provide to your customers. When you think about data monetization or embedded analytics at large, paying customers have high expectations when it comes to the data that they're viewing. So with DuckDB's unique compression algorithm, any query you run against this database, as long as it's within a certain size, is incredibly fast. And what we found in the majority of embedded analytics use cases is that the actual size of data that users are querying is relatively small. There's a lot of pre-aggregation going on. They're only getting access to data that they're allowed to see. And so with that unique combination of parameters, DuckDB really shines in this case. We've also already heard that MotherDuck allows for compute to be segmented by individual user. This is a feature I have not seen in any readily available data warehouse. And it's great because it eliminates competition for resources, which again, for paying customers, is important to have that reliable, low latency experience. And finally, the ability to operate in browser through WebAssembly also really sets MotherDuck apart in that having that database in the client provides query speeds that are basically as fast as your frame rate. Moving on to data reliability, this is where Cube comes into play. Semantic layers build trust. As Brian outlined, you can feel confident when you use a semantic layer that the data presented to your end users is reliably correct and well governed. Where Cube shines, in my opinion, is that because you can use JavaScript to build your data model, you can actually start to solve some more complex analytical data modeling questions or problems that other YAML-based semantic layers can't. Think like an EAV schema, for example. So you can provide that to an end user and still feel confident that the answers you're giving them are correct. And finally, Cube's GraphQL and REST APIs provide a user-friendly interface for application developers. So it's going to feel comfortable for a developer team to take over. They can focus on building great experiences rather than wrangling SQL. And I'm going to pass it over to David to talk a little bit more about presentation and then move into the demo.
So yeah, thank you, Spencer. You know, all the notes that Spencer shared are incredibly important because a great data experience can only be built on a strong data foundation. And I think Spencer did a great job of articulating how DuckDB and Cube.js can fit into that. But what I'm going to focus more is on the delivery layer, which is also critically important. What we think of as a web application user is the experience that we have, and not really all of the server-side foundations and data pipelines and everything that's happening under the hood. So what we really want to do is, in delivering data experiences, meet customers where they're at from a cognitive standpoint, from a physical standpoint, in terms of the kinds of questions they're going to be asking and what they're going to do with the answers they receive. We really like building web applications for a variety of use cases because it allows us to it provides us with the ability to fully customize that experience on the front end to meet the user's needs. In particular, React is a great choice. There are other very competent web development frameworks out there, but React is dominant for a reason. It's got a very strong ecosystem and total flexibility. And it allows us to build a solution that mirrors the experience that a specific audience is really expecting out of their engagement with your data. Additionally, it supports the ability to deliver custom analytical workflows. So when we think about traditional BI tools and the approach of embedding dashboards, what we're really talking about is more or less rectangles within rectangles. You have a rectangular dashboard with a bunch of tiles. What we can do is present data in a way that really kind of walks users through the process of asking questions and gaining answers till they're ultimately able to take action based on the answers they're finding. And additionally, we see in particular for a lot of analytical experiences that are integrated into SaaS products, there's often a desire to really fine-tune the branding considerations of that analytical experience such that it feels cohesive with the rest of the platform. And again, custom experiences are often a great and sometimes the only avenue in order to accomplish that goal. And then finally, we have ultimate flexibility in terms of both the information architecture, and by that I mean how content is organized from a navigational perspective and how content is organized on screen, as well as the interaction patterns, meaning the different ways that users can engage with the data, dive deeper, set up segments, take actions, make calls to different APIs based on the data that they're reviewing, and really be able to tailor that experience, again, to the user's specific needs. Finally, when it comes to presentation layer, we want to choose tools that allow us not only a high performance experience, because paying customers, particularly in web applications, have expectations that are kind of in line with other internet scale apps. So if you're used to using things like Gmail or Facebook or these other websites that are very fast, very responsive, and then you come onto a website that is slow to draw and has long latency when you're trying to take action or run queries, your expectations based on your common experience on the web are just not going to be met. So React has a lot of great performance optimizations that it offers, including things like server-side rendering and also the ability to plug and play very high performance visualization libraries that are using the GPU for accelerated rendering. Yeah, so just the notion that this tool chain offers very broad industry support, a huge ecosystem of open source libraries, makes it very easy for developers to rapidly spin up applications rather than having to write a lot of custom code on their own. So with that, I want to segue to our demo. And to set the stage, what we've done is we built a demo application that is a prospecting tool for medical device manufacturers. The main features that I want to highlight are the notion of tiered pricing, custom visualizations and workflows, a responsive data analytics experience within the app, very fast, low latency, and then finally adding value to an existing data set. So the use case, and this is fictitious, this is a demo application that we built specific for this webinar, is that we have a sales team of at a medical device manufacturer that has a product that can help reduce the return rate for people who have experienced myocardial infarction, which is a heart attack. So the use case is, as a sales team lead, I need to be able to identify hospitals that could benefit from our new device that we're bringing to market. The device is used to treat heart attack patients and lower the rate of readmission. And then hospitals with high readmission rates for indicating patients are our priorities. That's what we want to try to use this tool to identify. So at this point, I'm going to go over to my screen share. And here's our website. So we land here and we see a map of the continental United States and some golden KPIs as far as the number of patients who are returning for myocardial infarction, the total number of facilities, sales target, sales actual. And as you'll see here as I walk through this, this is really geared towards interactive planning. We want to be able to explore this data with very low friction, low latency, indexing on providing fast answers to our customers' interactions. So the first question, and all great analytical experiences always start with a question, is what is the best territory to focus my sales team? And I think based on this heat map I'm seeing, I see a lot of returning patients in the South, particularly in Florida, which you might expect given the demographics of Florida skewing a little bit older. So I can take a closer look. And as you see here, as I'm geographically filtering using the zoom function on my map, the golden KPIs that I'm most interested in are also filtering down. And if I zoom into, say, the Miami area, I can see we've got approximately 33 locations and 3,000 returning patients. So I've used this interactive querying tool, which due to smart caching from DuckDB, Cube, and in the browser, I'm able to very quickly filter geographically and see, be able to derive insights. I can also use traditional filtering, which you see more in typical dashboard tools by applying a state or using return ratio, percentage filters, and rerunning queries, as you might expect in other analytical tools and common BI products. So I've answered my first question. What's a great area to focus on? The next would be, what are the facilities that are going to be our top targets? So what I'm going to do is toggle my map layer, and I can see a scatter plot showing me different circles which are color coded from cool to warm. Cool means that the facilities have a low ratio of people returning, and warm has a higher ratio of people returning or being readmitted for heart attack incidents. And the size of the facility indicates the number of patients. So this, although it has a pretty high return rate, has a small patient population. So let's go ahead and start assigning some of my larger facilities. So I can see here all of my gray circles mean the facility's been unassigned. I can go ahead and take a look at the details of this particular hospital. It's the Miami VA Medical Center, and it's got a sales target of approximately $41,000. And I want to reassign this actually to Michael Jordan, not the basketball player, but the salesperson. I can click that button. Let's actually assign this over to Michael too. And I can, immediately I'm seeing my map update, and I can go ahead and look, okay, what's Michael's portfolio look like now that I've made these assignments? Well, it looks like he's a little bit overloaded. He's got 10 facilities, whereas some of my other salespeople have a lighter portfolio. So I'm going to go ahead and rebalance my portfolio and assign this to Chine instead. And so through this process of interactively exploring my data and making assignments, I can arrive at a good composition for the portfolio of my sales team. How might data monetization fit into this? How could you see offering different tiers as Spencer described? So the way we would think about this is maybe a free customer or the low tier might be able to access this view, be able to do some geographic filtering. They might even be able to see the scatter plot of facilities based on return rates. But what they wouldn't be able to do in the free tier is be able to gain details about the hospital facilities or make assignments of salespeople to a facility and integrate it with their CRM. Those would be features that we would presumably hold off for the paying tier. So I think with that, I've concluded the demo, and I'm going to hand it back to Brian.
Hey, thanks, guys. That was a great demo, and I really appreciate seeing the demo app that you put together and hearing your thoughts on data monetization and modern data app building. I know here at Cube, these are subjects that we see a lot of interest in, and specifically embedded analytics and data apps are really common use cases for Cube. So I definitely appreciate you guys being here today. I'm going to go ahead and open it up for audience Q&A. And if you are out there and if you have any questions, either for me or for Ryan from MotherDuck or for the team at Astrodata, Dave and Spencer, drop those in the QA and we will go ahead and get those answered for you. So I guess we'll give it just a little bit here. I guess while we're waiting. David, you guys, I know, are fairly new Cube partners. So do you want to just talk maybe just a little bit while we're waiting on Q&A on like what kind of getting up to speed on this stack was like, and maybe what the developer experience is like, and maybe tell the audience about that?
Sure. Yeah, go ahead, Spencer.
Yeah. I would say that it was pretty intuitive. I've used other data modeling tools in the past. Mostly YAML based, so JavaScript was a little bit of a new twist for me. But getting the initial data model built was exactly as I would expect. It reads the metadata from our data warehouse, allows us to specify primary keys, modify interpretations of that metadata, and then just automatically builds the data model for us. So that was really nice. The documentation was thorough enough to get me, comfortable writing JavaScript, even though that's a language I'm not super familiar with, in the context of building a data model. So from the actual semantic layer and data modeling side, it took me maybe a day or two to feel like I could start building an actual meaningful data model.
Cool. Yeah, and the only other thing I'd add to that, Brian, is it was really nice to have the option to use the GraphQL endpoint, whereas other modeling tools that we've worked in the past lean more on REST APIs, which, I could build queries that are much better aligned to the needs of the web page that I'm trying to render, and it just reduced a little bit of friction going from a query to a data display.
Yeah, that all makes sense. Thanks for giving us a little bit of insight there. We do have a couple questions coming in, or at least one in a comment. One question here. Have you guys thought about building any AI functionality into these applications? And I'll maybe give a little bit of context for that. We're starting to see the most common AI use cases with Cube seem to be extensions of embedded analytics or customer-facing use cases, where they're adding something like a multimodal chatbot, to give answers to people maybe who don't want to, interact with the visualization. Have you guys considered that, or what's Astro's stance on that?
Yeah, we actually do have one company that we have been talking to that are interested in just that. So within the enterprise, there is a dawning recognition that if you provide any kind of data access experience or search experience that is very data intensive, customers, again, are coming to expect a plain English interface or a natural language interface. So we've been wondering about when that's gonna, when we would have customers ask us for that, and it's finally happened. So we're pretty excited about that. new frontier in analytics.
Cool. Ryan, I've got a question here from the audience. This is a DuckDB question, so I'm gonna pose it to you. This viewer asks, do you see DuckDB as a platform for federating data across multiple organizations?
I think DuckDB certainly can be used for that. I think the question on federating data across across multiple organizations is what sort of level of access that you're trying to provide. And DuckDB does interop with things like Parquet files and things like Iceberg files. And so you can easily share those across organizations just using your cloud blob stores. The one nice thing about DuckDB that I really appreciate is that they did actually create their own file format, but their own file format does something unique in that it pulls all of the tables that are related into a single file rather than having a file per table. So that does make it a little bit easier for data interoperability and kind of transferring data to other users. One thing I'd encourage you to check out is the way we do sharing in MotherDuck. So visit duckdbsnippets.com. And that's a bunch of code snippets for DuckDB in general. But you'll find some there that do use the MotherDuck sharing model, where essentially you can provide a URL that gives access to a database. And you'll see a bunch of sample data and sample queries there. So there are definitely ways to do this. It's not our number one value point, but it is super helpful as you're sharing data across orgs.
Cool.
All right. Well, thank you, everybody. And thank you, speakers, for joining us. That was super insightful. And for you in the audience, if you have any questions, be sure to check out all the resources linked on the platform to check out Cube, Astrodata, and MotherDuck. And before you leave today, I just wanted to share upcoming Cube events. You can join us at Data Council Austin in March, and then Data Universe in April. I know MotherDuck will be there as well. And lastly, Semantic Layer Summit on April 24th. Have a good day, everybody. Thank you for joining, and we'll see you next time. Bye.
Thanks.